Hello everyone, this is Shihab and my teammate is Avilash Durgam. We are going to present our project which is Adversarial attack on cross-view geolocalization. Um, Let us talk about a little bit introduction on the adversarial attack. So as we can see, this is a picture of a panda and the main object, and if you perturb the panda image with some random noise or scaling or shifting, then yeah, we can see that this image is pretty much same as this panda image after the perturbation. So now if you feed this both of this image into a classification models, uh, now the question is, can this classification model differentiate between these two images, so the original image and the perturbed image? So that is the main objective. To find out this thing is the main objective of this our project. So as you can see is that this is one example where this is detected by the model as with 57% of confidence, and when you perturb this image with this masked random noise, then it is 99% confident that this is a given. So as we can see, this attack on a neural network can be destructive sometimes if we are using these things which requires real-time precise object detections. Now let's look into more on the kind of attack that we are going to perform. So mostly we are going to do our project on the basis of the gradient descent project gradient descent attack on a segmentation transformer based segmentation network, which is known as segformer. So what this project gradient descent PGD essentially does is that it gradually based on an alpha value gradually perturb the image from one step to another, so that it gives a final image and the detection process is done on the final image. And this adversarial attack should misclassify the image because of these random pixels added to the image. Now let's look a little bit on to what is geolocalization and why this attack would be harmful for for geolocalization. So essentially geolocalization is like given a query image. So this is like a camera this is like a front and rear view camera image from your car, and this is like couple of images this which is taken from like top view aerial images. So the geolocalization essentially matches this two image and saying that this is located inside this image or this image. So it's a like visual localization method. So the segformer or the transgeo, the model works in that way that if given a street view image and an aerial view image, so the transformer model matches these two image to create like an attention based layers, like yeah. So this part of this image is important for the model to figure out that this aerial view images matches with this street image. And so it is done in two stages. So the first stage is the matching stage, and in the second stage what it does is that based on the attention of this transformer model, it actually crops out the unimportant features for this. For example, this for this aerial view image, these buildings like the top of the buildings or like this parking garage might be unimportant for the model to say that yeah, this street view image is taken from this aerial view image. So in the second stage, what with the only the important images, the model actually detects that yeah, this matches the uh, street view image with the aerial view image. So this is just a simple transformer based model for geolocalization. Uh, so I will talk about the how how the attack is actually affecting the model. So as we can see, this is a part of this is the original street view image, which has been perturbed using the PGD. So now from the first image we can see that yeah, visually if you speak, this perturbed image looks a little bit like perturbed already. This is because of when we looked at the panda image and the noise that we added, we actually get that noise from like training the image on perturbed image. So that's like a masking, which will, by adding that masking with the panda image, we can classify it as a given image. So we didn't do that masking, so we essentially perturbed the image. So if you look at the original prediction, you can see that this is like a segmentation prediction for the original image. So this is house, this is house. So these blues are like houses, and this dark blue is like the streets. But if you look at our perturbed image, then we can see that yeah, you can't tell which one is the street. Like this is a street, and this is like a car. So you can see this is a car, this is a car. So the image is totally like perturbed. So yeah, that's like a result of for our model. Now I would like to Avilash to describe more about the attacking.
So let's look at what this untargeted perturbation attack has on our model. Uh, so the training on transgeo. So for training we use the ground view image plus segmented ground view image as our query image. Just a heads up, like this is part of my research about adding extra information to cross-view geolocalization algorithm. So this hasn't been done before, like no other networks implement it, and like it it is novel. So uh, let's see what happens. So the results are in, and the model still infers the location with similar accuracy. So this warrants further investigation about why it's happening. Why is this happening even when we are providing extra information and destructive information? It still fails. So the reasoning for results are, as mentioned earlier, this is novel and not been done before. So comparing the accuracies we get, we can see that the segmentation top 1 accuracy is actually lower than the normal top 1 accuracy, which is that for the same network, given a query image without a segmentation map added to it and with a segmentation map added to it, the one without segmentation map added to it performs much better than the one with segmentation map added to it. So we are actually providing our model with destructive information where it hampers the predictions. Um, so further investigation, like carrying on further investigation on attention maps, which is the positional embedding of the last token of the last block of the transformer model which we used, which is transgeo. We can get an aggregated attention heat map. So this is aggregated over all of the data set. So we have a 40,000 image data set. So if we aggregate over all of the data set of where the model is paying attention to, we can see that if the bottom part is the segmented image and the top part is the ground view image, all of the attention is being paid to the ground view image, whereas like segmented image gets next to no attention whatsoever. So this is a further reasoning for why um, why our why our experiment failed. So even though this adversarial attacks has failed in cross-view geolocalization, uh, there should still be more experiments conducted on adversarial attacks in self-driving and smart cars. So going off online, like certain we find certain uh, examples of where we have an authentic input and we add an adversarial perturbation and we get an adversarial input. So the authentic input actually signals a stop sign and adversarial input signals a yield sign, which if you think about it is pretty dangerous on the road. And yeah, your smart car or like Tesla shouldn't really be misclassifying signs. So these are our references. Thank you for your time. Have a good summer.